Good morning, everybody. Happy Tuesday. Hope you're doing all right. Alrighty, let's give that a pause here. We got a couple things on tap today. Hey, Super, good to see you. So let me make this quiet here. I don't know why it keeps beeping at me here. Does anyone else play Wordle? That's the new thing. Everyone plays Wordle in my family, and we all text each other our scores. So that's kind of been entertaining. Mike, you refuse, yeah. Trusaurus, you play? Yeah, it's an entertaining little game, for sure. I think they did a real nice job with that. So, it's a word puzzle game, which is interesting, and it's, I don't know if you've ever played the game Minesweeper. So it'll tell you if you have the right letter in the right spot or the right letter in the wrong spot, and you have 6 guesses until you lose to guess this little 5-letter word. But it's beautiful. There's no ads. It does some nice tracking. It's all like one little self-contained JavaScript app web page. And congratulations for Mr. Wardell. He sold it to New York Times for the rumor is about $1 million or so. It's just a fun little app. So it's something. All right, so a couple things today, though. We're going to talk about unit testing, moving on to new material here. This is supplemental from the text. So there's like little bits of discussions here and there. So I'm going to show you my preferred approach to unit testing, show you a couple of conventions, and then we can go from there. If you got any questions about Project 1, let me know. We can talk about that as well, because that one's coming up too. We got a little while for this one, right? That's 9 days, so a week from Thursday for this one. I want to talk about the lab today as well, and then we'll have a new lab for unit testing before we're done for the day. And then we should be in pretty good shape. Does that sound like a plan? Hope you have your coffee too, by the way. It's a good day for coffee. All right, so let's do the lab first. Let me grab this one here. So this was our practice with the drivable interface, and we're going to write some classes that implement drivable. So drivable was going to have 3 methods. It was going to have drive, given some kilometers to drive, which would return a Boolean, right? True or false. So true, you're able to drive that far, or false, you ran out of gas, bad thing happened. A get kilometers per liter, which returns a double, which should tell you how many kilometers per liter your drivable something gets. And then a get liters in tank, probably should have been in, no, that is liters, yep. Liters, returns a double the amount of liters in the tank of that thing that's drivable. So we don't know if it's a boat, we don't know if it's a car, we don't know if it's, is it considered driving if it's like a helicopter? Maybe? I don't know. Probably, that doesn't sound like something you'd say you drive, but I'm just going to go copy those real quick, and I'll start up a new project here in NetBeans, which I did remember to open early, which is pretty cool. I'm pretty excited. So I'll make sure we put this in the 2151 repository. This was lab 5. Piloting. Okay, so you pilot. Do you pilot a boat or do you drive a boat? Because like you're the captain of a boat, and you're the captain of an aircraft, but you're not the captain of a vehicle, right? I don't know. English is hard. English is hard. All right, so let me get rid of some of this cruft here real quick, and then we don't actually need anything here in main yet. Right, so we're going to start with our package, lab 5 package, and we're going to add some classes here, add some interfaces here. So we're going to do our interface for drivable, and we get the public interface drivable, right, not class, and then we just give it the methods. So I should just be able to paste that in here. Remember, all of our methods by default, give it a little format, are public. And then this is probably a double kilometers to drive, because you could drive like half a kilometer. Okay. Sail a boat, you pilot a boat. Okay. But would you say the boat is drivable? I guess you wouldn't say drivable then. Do you assume something has wheels then to be drivable? Is that what makes it drivable versus pilotable or something? So Boolean drive, given the argument, kilometers to drive, a get kilometers per liter, and a get liters in tank, both just returning doubles here. That's the interface. So that's the only thing it has. It just defines the public methods that are available if we implement the interface. Okay, and now we need to write 2 classes that implement this interface. So we can do car. Car's a nice boring one. Now you can add the interface here if you want, or you can just type it ourselves. Okay, so you had way more. Yeah, I mean you can add more things to it for sure. This was the starting point, the minimum. Like no big deal there. Right, so then we get car, and then we'll say, remember, we implements drivable. So we implement an interface, and then right off the bat, Java gets upset with us and says, oh, hey, it doesn't implement all those things. Do you want to? So if we click the little light bulb here, we get our little shortcut to implement all the abstract methods. Now, their default version here is bad. It just throws an exception, which is not what we want. So let me just go undo those real quick. Okay, so we've got the methods here, but then car still needs its own attributes, right? We still need something about car. And they didn't ask for anything in particular, just make sure that you can drive one. So anything you wanted to come up here with was great. If you just wanted to have like a string for the make and the model, sure. If you didn't have make and model, that's okay too. But then we're going to need a double for the kilometers per liter, right? To actually be able to store that. I don't know what kilometers per liter, and then liters in tank. Private double liters in tank. Yeah, it's okay if you didn't have the strings. I just was adding them in for fun, because you can have more than what's in the interface in a class, but you can't have less than. Right? You must have at least what's in the interface. Right, so then for get kilometers per liter, we can just return the kilometers per liter. And for the get liters in tank, we can just return the liters in tank. You went in class, dear. Yes, give the cat some food. Thank you. Oh, one of the kitties wanted to come say hi. now she's chasing my daughter because she's going to give her wet food. It's like those little cans of wet cat food are such a treat. All right, and then we got make, and we got model. So, again, those are other things we could add in here. So let's just right-click and do insert code. We don't need to type them ourselves. Let's add those as getters. We can add gets for make and model as well while we're here. And then we need a constructor. Now we have the liters in tank. That's going to track how much is currently in the tank, but we probably want to know the capacity of the tank, right? Like how large the tank is. Maybe we could add in something here. So like the max, or, I don't know, tank capacity in liters. Again, using this liters specifically so you know what the unit is as we go here. Yeah, because now we'll know how many gallons you can, or how many liters you can put in the tank before it overfills. So we add another get here then. And again, if you didn't have all these, that's okay. It'll mostly work without. It might be a little bit tricky, but we can make it work. All right, then we want a constructor. So we'll insert a constructor. And which of these things we want to make? We want to model. We want the kilometers per liter. Maybe the liters in tank and capacity. Definitely the capacity. Maybe the liters in tank, or maybe you say, hey, our brand new car starts with a fresh tank of gas, which is, would be nice if that actually happened. But I guess the dealership has to do that for you, right? So either way, let's not have the liters here, and we'll just assume that starts off as max. So I'll take my liters in tank, then it will set it to the capacity. So we'll give it a fresh tank of gas when we go here. And then remember, these values, gets are good. So we are exposing the value to someone who sets them so they can go get the values later. They don't always need sets, right? Like once you have the make and model of a car, I don't think that ever changes. Right? And, it's going to depend on your class. So some attributes will change and some will not. So, my Ford Transit is never going to be anything other than a Ford Transit. That's what it is. Now, the kilometers per liter is a bit of an oversimplification. This is just our average here. And this can change, maybe, over time and with other things in the vehicle. That's probably more complex than we care for a little lab exercise here. So we're not going to say it's changeable. We'll just set it once in the constructor and leave it. The gas tank capacity definitely doesn't change unless you put a new gas tank in, which I guess you could do, but again, probably not a changeable value here. So the only thing that really changes is the liters in tank. And the idea with the liters in tank, when you interact with a vehicle, some sort of car, right, you don't walk up to the gas station and say, hey, I want 10 liters in my tank. Done. No, you add gas to it, and then when you drive, the gas comes out. So we can add some sort of method here, like add gas, given a double liters to add. And then we can do some sort of arithmetic here, right? We can take our liters in the tank, and we can add the liters to add. And then we probably, liters in tank. That's the wrong liters here. Liters in tank. Probably want to do some sort of sanity checking. We should say, hey, if the liters in the tank, liters in tank, went over the capacity, a bad thing happened. And really, we're not allowed to do that sort of thing, so let's set the liters in tank then to the capacity. Right? If you tried to put in 15 liters and it didn't all fit and it spilled, well, bad stuff happened, and we're going to return false here because a bad thing happened. Otherwise, you can return true, it worked. Again, not necessary, but this is good practice when we're thinking about making classes, right? How do we interact with them here? And then for drive, right, we're going to take gas away. So to figure out how many liters you need, right? So we need a double for liters needed is going to be the kilometers to drive divided by the kilometers per liter. Right? If you get 10 kilometers per liter and you want to drive 100 kilometers, 100 divided by 10 will say you need 10 liters. We'll take our liters in our tank, and we'll subtract the liters needed. But then we also want to do a quick little sanity check, right? Because this is a Boolean. If the liters in tank is less than 0, well, you can't do that. You ran out of gas. So we'll set our liters in tank to 0 and return a false. Hey, this was no good. Otherwise, we can return true. Life is good. Right? You were able to drive your 100 kilometers. We used the 10 liters. Life is fine. That part make sense? So again, maybe a little bit extra on some of these things, but drive for sure we need something that returned a true or false, and it should have like reduced the liters in our tank, right? Because we had the get liters in tank as an interface method, and a get kilometers per liter. So some way to add gas, great. If you didn't have it, that's fine. If your constructor set it, good. If you didn't have a way to change the liters in tank and you never set it, it was always going to be 0, and you'd never be able to drive. So you need some sort of way to interact with liters in tank. Not too particular about how that is. But does that make sense for the first class here that implements drivable? Again, maybe a little bit more than you were thinking, but that's okay, right? That would work okay? All right, awesome. Thanks, Shady. So let's do another one. So let's do another class then that implements drivable. And let's see, so what you can drive, we drove a car. Do you want to do, so you think boat was no good for this then? Because you don't really drive a boat? A tank. Okay, let's do a tank. I like it. We'll do a tank. The tank then implements. So tanks probably get like, what is it, liters per kilometer then instead of kilometers per liter? I don't know what kind of gas mileage a tank gets. Implements drivable. And now what's different about tank? Well, probably not a lot. Actually, it'll have maybe some different attributes. So again, these ones here we can get rid of. We can fix those ones up. So we need at least some of those same attributes. Kilometers per liter, gas tank capacity. Now, tanks might not have a make and model. I mean, I guess they kind of do, right? You can have like a Sherman tank, I think is the other one that rings any bells. And what is that from? There was a game. Was it Command and Conquer where you had tanks, Sherman tanks? I forget what it was. Some game that had that. And then we can just return our kilometers per liter. And we can return the liters in the tank. It's in the tank. And we've got a capacity. Great. What else do we want to know about tank? Maybe tank has... what fun methods could we add for tank? We could add a public, maybe void smash. And then I don't know, we just return tank smash. I don't know. An M1 Abrams, 0.6 miles per gallon. So, okay, so a gallon's about 4 liters, and a kilometer is about 0.6 miles, right? It's 1.6 kilometers per mile. I remember that from track. So it sounds like you'll get like 4 kilometers a liter? No. That's for 4 liters. You'd get 1 kilometer. Oh, wow. For 4 liters, you get 1 kilometer? Does that seem right? I think that does check. That's pretty sad. All right, so we get, well, that's a string here, right? To return tank smash something. How about a string, the target? Tank smash plus the target. Sure, we can do that. And then we'll add our constructor. Add a constructor. So we want the kilometers per liter. We want the tank capacity. And then we want to set our liters in tank to the capacity. And a lot of this is a, that's okay. It's the logic is the same. Things drive very similarly, but other things can be different, right? Tanks can smash things. We want anything else for tanks? It's probably okay, or maybe this could be the M1 tank here specifically. Right? All right, so we have our 2 classes to implement. Then we're going to make a loop that drives the vehicles until they run out of gas. So back in the actual part of our code that has a main method here, we'll make 2 of those. We'll make 2 vehicles. So we'll have our car. This was my transit equals a new car given, and then our, oh, come on. We need string, string, double, double. It's telling me real small. It's not giving me the nice little type. There it is. String, string, double, double. So it was a forward, make, transit, and then it has, let's see which one was first. We needed the kilometers per liter first. So I get about 12-ish miles a gallon. So divided by 4 is about 3 miles per liter. And then 3 times 1.6 is going to be about 4.5. We'll say 4.8 kilometers per liter in my Ford Transit. And the gas tank capacity, that thing holds 25 gallons times 4, about 100 liters or so. That sounds about right. And then like a tank, how about the M1 equals a new tank? And then tank just needed the kilometers per liter and the gas tank capacity. So we said you were getting 0.25, right, kilometers per liter, and that capacity must be huge, right? I don't even know how many gallons. So we'll say like 500. We'll say 400 liters is about 100 gallons or so, maybe. I don't know how much they put in there. Okay, so we'll make 2 instances, one of each kind, and then we'll go drive them until they run out of gas. So we can say while transit.drive, like 1, we can just drive 1 kilometer. We can do that, or we could get, use the arithmetic to find out how much gas is in the tank and how many liters they have, but either one could work here. And we'll say driving the, and then we want what? Car plus get car dot, oh, transit, sorry, transit. No, Cortana, not you. I don't know why she thinks I want help. Transit dot get, we'll just do the model. Plus, I don't know, 1 kilometer. Sure. And then we can do it again with our tank. While the M1 dot drive, 1 kilometer. That's M1 dot. Now we don't have any of that make and model, but we have M1 dot smash. And what do we smash? What do we want to run over here? Smashing. What is what can we run over? And flatten old cars. Smashing pumpkins. Pumpkins. I don't know, smashing. We can just do smash, right? Tank smash, pumpkin. For 1 kilometer. Sure. And let's see if this one runs. So it should give us a big output. So the transit then should go a bunch of kilometers, right? We had 100 liters, we get 4.8. So 480 of those. Well, that's going to be fun. 480. And then the tank then should smash things a bunch. Now we had, what do we say, 400 kilometers, but we took 4 each. So it should be 100 for that. Sure, and we could add some counters and do that sort of thing, but it just runs until we run out of gas, until this returns false. Give it a little format. This is just having fun playing with our interface. Again, don't really gain a whole lot here. Remember, the fun thing that we can do with interfaces is we can put them in a collection here, and then we can use them. So we don't know this make and smash here. They're not great. But what we could do is I could make a collection, or like say an array list of type drivable. Here's my vehicles, maybe, equals new array list. And then we could take my vehicles, and we could, oh, we gotta add our import here. Vehicles.add, and then we could add in our M1, and we could add in our transit. Because both of them can be treated as the type drivable of their interface type. And then I can do a loop. I can say for drivable vehicle in the vehicles collection. Then I could do my little loop here and drive them here. While vehicle.drive, because I have a drive method. I don't know, driving the... Now the problem is the interface doesn't specify anything other than this. So we really have no idea what it is in something. Because, you know, okay, that was our fault in the interface. Maybe the interface should have had like a get name, right? That could be fun. Right, or we could add in here, even better, we could have a string, toString, right? And this one then would override the object toString, which would be helpful. Now, you'll notice we changed the interface, and none of these complained here, because they already get that default implementation of toString, which is not necessarily the best one here. Then we could say vehicle.toString, and we're going to get ugly things here. Right, we get car at, right? This is the name of the class at memory address here. Tank, name of the class at memory address here. Right, these are ugly because the object version here from the base class gives you an implementation for toString, but it's not all that useful. So we want to add some overrides here. We'll override the public string toString, and we can return make plus model. Right, so that's probably pretty. And for the tank one, then we can just return public string override public string toString. We can return tank, or maybe smash. I don't know. We don't really want to smash there. So now when we run it, we'll get the better looking version here, because we overrode what toString is. So toString is a pretty common one to override. So you get a nice little tank 1 transit instead of that class name at memory address. Right. So again, that was extra. We don't necessarily need that, but that would make this be a little easier here, where I can treat them as their interface type. I don't care what version you give me. I just know that I can go drive them here because that's what the interface says. And I had a couple questions about interfaces. This doesn't seem all that useful, right? Even being able to do this is not the most interesting thing in the world. But as your projects get larger and larger and larger and more complex, what's really nice is that you can write interfaces before you have any working code. Right? Before you actually have the class for car and tank, you could write that drivable interface, and then you could write this list here, or this little loop here. Right? We could work with some sort of vehicles without actually knowing how they're implemented. So someone else on another team, or someone else on our team, or whatever it happens to be, could be their responsibility to go write the classes, but our code works. Mr. Pup, so I did one per class. So I said the interface should have a toString here, and then car and tank should override it. So tank has its own version and car has its own version. But the specific version that's going to run is the first one in the hierarchy. So car has a version, so car's version is going to run. When it didn't have a version, it starts looking up that hierarchy. So car technically extends object, right? Everything in Java extends from object. So everything will have a toString, and that was that version that says, here's the name of the class at a memory address. So if you don't add your own and override it, you get the object version. And then it knows which one to run because of polymorphism. Right? That's our technical term for this. So I'm treating it as the interface type, but Java knows at runtime which actual type it really is, and it will run the correct version here behind the scenes. So as it's running, we're treating it as a type of drivable, but it knows, okay, you're actually a car, or you're actually a tank here, so I'll run your specific version of the toString here. Okay, so let's look at our interfaces here for the project. The idea with the interfaces here is that we don't necessarily need to have the working code yet, and we'll still write it eventually here for the project. but we can just come up with the interfaces to say, okay, this is what it looks like. So if we're going to split this up as like a group project, right, in our little Animal Craft game, this is buildable or is diggable, is choppable. We don't need to worry about the space classes yet. Someone might be working on the space classes separately from us, but then we could go around and we could see, hey, if the space implements the interface, let's use the tool. So is buildable is going to have some sort of method like build on it. So if the space implements is buildable, right, is a type of is buildable, then I can call build on that space without knowing what particular class it is. Right, so I've got the space class, and then I have specific versions of the space class that implement different interfaces. So I might have a buildable space or a diggable space or a choppable space. I don't have to have any of that written yet. I can just build the interfaces and say, okay, hey, if that space implements the interface, let's go do it. And then later I can add those classes in behind the scenes to make that stuff work. And then we get this nice little flexibility here. So everything looks like a space, but then I can have specific types as I go, and I want to change my game. If I want to add more features and functionality, everything is still this base class space here, but I can add new interfaces, and I can add new tools, and I can add new ways to interact with it without having to change any of the original stuff. So that's kind of the idea there. So it lets you have the contract, right? It will look like this. Here's the methods that will be available, but you don't have to have the implementation yet. And you can kind of separate that apart. This idea that we want to build classes so we interact with their abstract public interface or their API. Interfaces let us work with abstract classes, essentially, because we don't need to know how they work. We just need to know they will have these methods. And then you get this really cool polymorphic behavior where you call toString or whatever method, and it will find the correct version to run at runtime. So it's going to go find, okay, you want the car version because you're actually a car, or you want the tank version, you're actually a tank. This sort of thing. So it's going to build on itself. Right? So we're kind of wrapping up all those principles of object-oriented programming. Right? We've got the encapsulation, where our class is this little self-contained unit. We've got our private attributes with public methods, that abstraction, they interact with our public methods. We get this polymorphic behavior when we can treat them as a generic parent type, essentially, whether or not that's the class that they're extending through inheritance or a class that they're implementing through interfaces. We can treat them as that type, but then we get their correct specialized version here. There's a lot of fun stuff, and it's going to take a little while, and we're still new at it, so it might not be, super clear why it all works the way that it does, but don't worry too much about it, if that's okay, to say, let's play with it, practice with it for a little while first, and then see if some of it clicks. Man, I'm almost out of coffee here. Let me see. I think, yeah, I brought my pot up here, which is nice. Get a little refill here. I am really excited for when we can get back. Hey, super, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. I got it all out in one breath this time. That's so cool, my friend. All right, so let's take a look at unit tests. Let's shift over to the new stuff now. So we talked about the lab, we'll move into the new stuff, and then we'll talk about the lab for unit testing that we'll work on this week. That sounds like a good plan? So I don't think we'll do a lab today and on Thursday, so I'll give you the lab for today, and then that'll be due a week from today is going to be the 15th, right? And then we got the project due on the 17th. So I think that'll work out well. So if we start the unit testing lab today for lab 6, we don't have one on Thursday. That way we'll have a lab due Tuesday and then the project due Thursday. I think that should be a good flow if that works out for you. And then we're going to talk about exceptions next week, and I'll give you the practice midterm, the one from last semester, because I have 2 semesters. I think I was over the summer. I didn't teach this one last semester, but I'll give you the one from over the summer, so you can get a feel for what the questions look like, because I've got to rewrite them anyway, thanks to amazing websites like Chegg, which we have all agreed is terrible and we're not going to use, but just in case, we got to rewrite those exams. Okay, so we got midterm week. We got the whole week to work on that. Again, sometimes the class is a 4-credit class, all in one sitting, so you just do one night of 4 hours. So I want you to have that whole 4-hour in-class time set aside for this to work on it. And then we're off for midwinter recess. So we'll actually have a week off. Nothing should be due. Everything should be done and out of the way after our exceptions. And then we'll come back with Java FX. Pick this up again. We'll look quickly at Chapter 17, that's the textbook chapter, and then I'll show you a bunch of supplemental stuff the week after that. And then we'll get into some really interesting things, like working with databases in Java, these Lambda expressions. These are like shortcuts, essentially. We'll look at some of those. And then multi-threading is a lot of fun. This is where programming gets crazy. And you'll spend a lot of time, if you do continue on in a computer science program, looking at multi-threading and how this stuff works. It's kind of amazing how computers do things. So we'll just take a look at some of the basics, essentially, how we can take advantage of it. And then we'll talk about our final project, and that's what we're doing in April. So we got a little bit of time. We'll talk about annotations and design patterns, some supplemental material as well. And then we got 3 sessions set aside for that final project work time. Again, ideally we're doing this in pairs, maybe a trio, depending on how this shakes out after the midterm. So we'll see if we got an even or odd number of folks want to work on this. So we'll have some time set aside. We can get together and I can, scoot around the groups and make sure you're on the right track here. And then April 28th, you guys will be presenting your projects. So we'll just take turns. Everyone can show off their final project, and we'll take a look and see how it goes. And that should be a lot of fun. So I know it just started becoming February. But we're already looking ahead to the end of April, and by then it should be warm again, or warmish, right? Maybe not super warm. So that sounds like a plan. We know where we're headed at least. All right, so let's spend a little bit of time talking about unit testing. So we've got some classes here already. We've got car, we've got tank. Now, one of the things that's important is that our code does what it's supposed to do correctly. So we wrote some logic here for add gas, we wrote some logic here for drive, and we think they're going to work. But like you probably remember from writing your English papers, just because you think it's supposed to do something and that's what you meant for it to do, doesn't always mean that's what it does. So the only thing we've done so far is we go over to our main method and we make an instance of that class and we start calling methods. Like, can I call drive and will it do a thing when I call drive? Right, and we saw, okay, we got an output. So we're using our eyes, essentially, to say, okay, I expect this to happen. Does it show up on the screen and look like what I expect to have happen? And turns out people are really bad at this sort of thing. Right, this is not a strong suit of humans to over and over and over and over look at output, compare it, and see, does it look like what we expect? Right, so it turns out who's better at this is computers. Computers are really good at that sort of thing because they don't get bored. Right, and they will do exactly what we tell them to do. So we're going to put this work off on the computer to do the validating and testing to make sure it does what it's supposed to do. That's our idea with unit testing. So we're going to make the computer do these tests. And the idea with a unit test is it's going to test one small unit of code at a time, generally one method at a time. We want to test here to make sure it does this one thing. So there's other levels of testing. If you take a software engineering class, you probably heard about integration testing or system testing or end-to-end testing. We're not going to worry about any of that right now. We just want to focus on unit testing because that's the easy one to pawn off on the computer. Okay. So I'm going to go to my class that I want to test here. I'm going to right-click and say, navigate, go to test. So this is in NetBeans. There's other tools will have very similar approaches for this. But for now, navigate and go to test, then is going to say, oh, do you want to create or update tests? Yeah, I want to make some tests. So you want to make sure now that, unfortunately, the JUnit version doesn't play well with Java with Ant, which is a big bummer. So don't pick JUnit in the framework here. This one's important. Pick JUnit 4 because this one is going to work with our Java with Ant projects. Okay, and we're going to put it in a new test package, which is great. So when it comes time to actually package all of our code up and deliver it somewhere for someone who wants to run our amazing code, we can exclude test packages from that sort of deliverable. So putting them in separate Java packages is important. And then there's a bunch of checkboxes here. We don't really care about most of them. You want like these first 3 method access levels checked and then nothing in the other ones checked. This is generally what you want here. And we'll say, okay. So it's going to make a new package, and it's going to scaffold in a bunch of code for me here. So now I have this test packages over here. I get a lab 5 test packages, and I see car test. And in car test now we have a bunch of methods. We get a constructor, don't worry about it, and we get a bunch of these at tests. So at test is the annotation that tells Java, this is a test we want to have run. So we can test a bunch of these methods here. Now, in general, I'm not fond of testing get methods, because doing it one at a time is really tedious and obnoxious. So I'm just going to go in and delete any of these that are just test gets, because I don't want to do any of those. And the test toString I'm going to get rid of as well, because we'll test that one in here in a minute. So what we're left with is add gas and drive, the methods that actually go and do something. So here's the add gas method, here's the drive method. All the gets we can get to in a minute. So we're going to add one ourselves here. So I'm going to add a new method here, at test for public void test constructor. I want to test the car constructor. Now in this constructor here, I'm going to test all of the gets all at once. And I'll feel okay about that. It's not one small unit of code, but what I'm testing is the constructor unit of code. And one of the jobs of a constructor, remember, is to give values to all of its attributes. So if the constructor's job gives all of the attributes values, I can go use the get methods to see what the values of those are. Right? So I can use all of those get methods all at once. This just saves a little bit of time here. Now, what we're going to do in our test code is a convention. We're going to do this AAA convention. And what that means is we're going to arrange, we're going to act, and we're going to assert. So for arrange, we're arranging all of the code that we want to have in place. So this is getting everything set up. So arranging is setting up variables for testing. Acting here then is actually calling the code we are testing. We are testing. And then assert is checking if we got what we expected. Okay, so for arrange then, I'm going to set up a bunch of, hey, this is what I expect to get back. So I'm going to have a string for expected make. Here's a Ford. I'm going to have a string for an expected model. Model is a transit. I'm going to have a double for the expected kilometers per liter. What did we say? That was like 4.8 or so. And then a double for expected capacity in liters. We said, what was 100? I think 100 liters or so. That sounds right. Okay, so these are all the values that I expect to get back out. Then we're actually going to act and call some code. So for this one here, it's our car. Car equals a new car. Given the, and now this constructor needs the expected, it needs a make, needs a model. So we'll give it the expected make. We'll give it the expected model. Why is the type ahead not working? Expected model, there we go. Give it the kilometers per liter, and give it the capacity. And a semicolon, right? There we go, semicolon. It's getting a little long there. Maybe I'll drop that down the line here so you can see it all on one page. Okay, so the code that we're calling here is the car constructor. So this is what we're putting in act. Then we're also then going to get any of the values back out and get actual values. Actual values. So now we're going to use this instance of car, and we're going to have an actual make here. So what does the car think its make is now? Right? What is the car? Type ahead. And then a string for the actual model. Right? What does the car think its model is? Get model. Oh my goodness, that instance of it is driving me crazy. And then a double for the actual kilometers per liter. Car kilometers per liter. And then a double for the actual capacity. Capacity in liters. Car.get capacity in liters. Now I'm also going to have a actual double actual gas intake in liters, right? So we want to check that. So I don't have it. I guess I could have another expected value for that. So expected, this is gas intake in liters. And what I'm expecting to get here, I'm just going to say, hey, is whatever that value is. Get gas in tank in liters. Get gas in tank in liters. Oh, get liters in tank. Get expected liters in tank. There we go. I like when all these match. That makes me happy. To an actual liters in tank. So these are all the just using the gets here. Right? And then maybe we'll have an expected, I don't know, how the string value should be a Ford Transit. And then a string for actual, an expected string value. And actual string value is car.toString. So we're just testing all of these methods here, right, to see if we make one, do we get all these back out? These are toStrings almost like a get. It's not very exciting here. So I think that's fine to add in here. Okay? And then we're going to assert, did we get what we expected? So to do that, we say assert dot, assert equals. So there's all sorts of assert methods here because we are inheriting, no, it doesn't even show that. We're just calling the method. So we're using these JUnit tests here. So that we get all these assert methods here. So that method came from importing this JUnit library here for asserts. So we give it the expected and then the actual. So the expect to make and the actual make. And we're just going to do a bunch of asserts here for model, for kilometers per liter, for capacity in tank, for liters in tank, and the expected string value. And we'll go and update all of these ones here one at a time. I know it's going to seem a little tedious, but this is going to make the computer do that checking so we don't have to eyeball it and say, okay, does it look like the actual value here? And then we'll give it the expecteds. So I'm just double clicking and then copy and paste. Double click to highlight and copy and paste. I'm fond of not typing if I don't have to. Okay, so we're going to assert then, did we get what we expect? And the computer then will check, do these things equal each other? Do these things equal each other? Now, when we get to doubles here, we do want to be a little bit careful because remember Java's bad at math, and if you like add a bunch of doubles together, sometimes you get that like trailing millionth decimal place. So anytime you're comparing doubles here for these three doubles, what you want to give it is a delta. So the delta is like how close is close enough for this. So we'll say, hey, as long as it's within like 0.000001, what is that? The 100,000th, we'll say a millionth. As long as it's within a millionth here, we'll call that close enough to equals here. Now what we can do is we can actually run this test code. So if I right click and say test file, it's going to run the unit test and tell me if it passes or fails. So the computer is going to do it. So I want to open this test result window and it'll show. Now, if it doesn't fail, it passes. So test add gas and test drive technically pass because they didn't fail, which is a little bit weird, but our test constructor passed. So all of this code ran and all of these matched here. So again, if we were to change one of these things, so the expected string value here, we'll just put test compared to the actual string value. Let's run this one again. I'm going to right click and test file. We're going to see it's going to tell me it expected a value and it didn't get it here. So it says, hey, test constructor failed. Right? And we can see expected test, but was Ford Transit. So you can get this little error message and it will tell you this is what we expected and this is what we actually got back. If we're following this sort of here's our expected, here's our actual. So we can see all that worked. Now again, this one probably doesn't seem very interesting, but now we've verified we can give the constructor values and we get back out values. Hector, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. I'm getting better at that in one breath. Thank you, that's so fun, my friends. All right, so again, this one's probably the boring one. It's a lot of typing here, not a whole lot of gain out of that, but we've made sure that we're properly able to pass arguments to our constructor and get them back out. Because it is easy to make some typos here. Like if I were to mess one of these ones up here, or if I forgot my this dots, right, I'm going to get defaults. So it's a good check here. Now the next one that's important is our add gas and drive. Now add gas here, we had two things that could happen, right? One is we could get back a false result if we overfill the tank, and the other one is we get back a true result. So when you talk about unit tests, there's this idea of what we'll call code coverage. And code coverage is simply how many lines of code are actually being run when the unit tests run. So if I call add gas and I add 10 liters of gas and I don't overfill the tank, these 2 lines of code here are never run. So in terms of code coverage, I get this line run and this line run. So I really get 2 out of 8 or 2 out of 4 lines of code run. So for the code coverage, I only get like 50% here. Now, there's all sorts of cool tools you can pay for that measure that sort of thing. We don't have any of those cool tools, so we're just going to essentially eyeball this. We're going to say, okay, I'm going to look at my tests and look at the method here and make sure I can get to 100% code coverage. So for that to happen, I need to run a test that makes sure I can get a true result and run a test to make sure I can get a false result so that these lines of code will run and this line of code will run. So I'm going to need 2 different tests here for that. So for test add gas, we'll say this is successful, and then we'll do another one where we are unsuccessful. Or I don't know, returns false maybe. That's probably better. Returns false. Probably cleaner here, and maybe it returns true. So we're going to change the name here, right? You want the name to be nice and meaningful, and then we're going to go do something with it. Right? Now the problem is our car, right off the bat, when you make a car, fills up the tank to capacity. Okay, so we're going to have to cheat a little bit here. So let's do the false one first. That should be the easy one. So now, when I go to test it, I don't actually care about the make and the model. I do care about the gas tank capacity in liters. And I technically care about the kilometers per liter. Well, we'll see why that's important in a minute. So I'm going to do this arrange. We're going to act, and we're going to assert. Now at this point, having a car to test is not what I'm testing here. I don't test the constructor, so I'm not going to put that in the act section. I'm going to put that in my arrange section. So I'm going to say car with a new car. Given, I don't care about the make, I don't care about the model. So I'm just going to give them empty strings here. We don't need any of those. Now I do care about the kilometers per liter, and I do care about the capacity in liters. So I'm going to take both of those again. Now I want to change this because 4.8 is going to be a little tricky here. I want something that's going to be easy math. So I'm going to say, how about even 10? So 10 kilometers per liter and a 100 liter capacity. So I can pass both of those into the constructor here. Now I've got a car that I can test. Then I'm going to try and add some gas, and it should return, oh, we want the return false. I'm sorry. I want to do the false one first. So a brand new car is not going to be able to take any more gas here. So then I'm going to have when I go act, I can say car.add gas, and I can add like 1 liter here. And that should return a value. So I need a Boolean for the actual result is car.add gas. And then in my assert now, I can say assert false. So instead of saying assert equal, does false equal false, I can just say assert false as a shortcut here, given my result. So this is a little shortcut. You could say assert equal false, and like an actual result and the unexpected result. But this is just as fast here. I mean, faster, actually. Okay, so there's that test, and let's run it. So you can click the little play button over here, and we want to run the test. And we should get some test results in a second. So add gas returns false works. Looking good so far. Okay, so I'm going to grab all of this. Now let's do, we want it to return a true. So in order to be able to add gas to the tank, we need to not have gas at capacity. So I'm going to say car.drive here because I can't change the amount of gas in the tank directly. The only way I can reduce it is by drive. Right? So I'm going to drive the kilometers per liter, I don't know, times my capacity. How about that? So that should get me down to 0. And then when I add gas, I should get something back. So then I'm going to have a double for expected gas in tank, or liters in tank. We should say is 1, right? So if I go add 1 liter of gas here, I should get back a true, so I can assert true. And then I'm going to check, hey, how much gas is actually in the tank? Right? So then we'll get a double for actual liters in tank. Here's my car.get liters in tank. And then we can assert those are equal. Assert equal. My expected liters in tank, expected liters in tank, and the actual liters in the tank. Now, if you just run this one without that delta, it's going to yell at us. It should. Watch it not. Yep, there. So here it says, hey, use assert equals expected actual delta to compare floating point numbers. So it doesn't even work here without that delta. So again, you know, something, it doesn't have to be like specifically millions, but something close, like some small delta here is much better. And then we'll run our test. So if I empty the tank and then I add 1 liter, I should have 1 liter and add gas should return as true. So that's looking good so far. Okay, does that make sense why we have 2 different tests in car? Because we want to get that code coverage. We want to make sure that this block of code runs in one of our tests and that this code runs in one of our tests. So we're testing both cases. So anytime you've got an if or an else, or you've got some sort of blocks of code, we need a test that will make sure that that one will run inside the method. Right, so that's how we're testing add gas. We have 2 different tests for add gas, so we can get good code coverage. Now, 100% code coverage is a fantastic goal, and you know, I'm going to argue very hard that any code worth writing is worth testing, because why would someone pay you to write code, or you know, why would I ask you to write code for class? But in the professional setting, why would someone ask you to write some code and not care if it does what it's supposed to do? Well, yeah, maybe we could go test it ourselves with like a main method here, but this is prone to failure. You can still screw these up here. It's possible to mess up your unit tests, right? But it gives you a little bit better of a feeling that it does what it's supposed to do, because for you to mess it up, you have to mess it up in the class and you have to mess it up in the test, which is possible, but it makes your code more likely to be correct, because it's doing what we expect it to do. Now, that doesn't mean we can't have logical errors, right? It's very easy to do the wrong thing if I'm not solving the problem correctly. And then when I test it, I'm going to test that it does the wrong thing because I don't understand it properly, right? Like if I'm not properly calculating how this works with my liters in the tank, or if my arithmetic here is wrong and I'm repeating this wrong arithmetic in my test, I'm going to get the wrong result. And I'm going to test that I got the wrong result. So it's not perfect, it's not foolproof, but it gives you another layer of, hey, let's make sure it does what we think it's supposed to do here. And then we don't have to make someone run this every time and eyeball the results and say, okay, it looks like I'm getting the right numbers back out, and do a bunch of gets. Does it look like I got the right stuff out? We can let the computer do all that checking for us. Right, so for drive, we're going to do both. Then it returns true and it returns false. So we're going to add 2 different drive test methods, returns false and returns true. Okay, and then we're going to do this little arrange, act, and assert again here. So right off the bat, a car should drive nicely. Right, so we don't need the add gas. We want car.drive. Now if we just drive a kilometer, it should drive. Let's actually drive 10 kilometers here. And then I'm going to have a expected liters in tank. So if I get 10 kilometers per liter and I drove 10 kilometers, right, I should have this minus 1 left over in my tank. And let me go copy that line here because I want to do that. Get the actual, I copied the wrong one for my test. So we act, we'll call drive, and then we'll get the actual result. Then we can compare the actual result. So drive should be true, so we're going to assert true that it worked, and then we should have 1 less liter in our tank after we drive 10 kilometers. That should work. Let's see. So run that one. Cool, that one passes. Awesome. Let's go back. Now, for false now, if we... let me just copy paste this whole thing, actually, because I added in those 2 extras. Now, if I drive more than I can go, I should go down to 0 liters left. So if I drive my capacity, or my kilometers per liter, times the capacity, plus 1, right? 1 past where I'm supposed to be able to go. That should give me back a false result. And I should have 0 liters left in the tank, right? Because that's what we told the car to do. You just run out of gas, right? We're not going to let it be negative, right? The class should protect its integrity. You can't have a negative amount of gas in a tank. It breaks the laws of physics, right? So we're going to make sure that doesn't happen. But we're just going to stop at 0 and then tell them, hey, false, this didn't work for you. Okay, so we'll run that test. We're saying, okay, should get down to 0 then if I try and drive more than I can. And that one passes. Okay, so now let's run them all. So we'll come back to the top. You can just right-click Run or click the play button. Oh, I thought I had it. It's not there. That's all right. Right-click and test the file. And then our car test here should run all of the tests. And we'll see all 5 tests pass. We get a lot of green check marks, and we're happy. So that's the basics for unit testing. So why don't we talk about the lab, and then we can break for lab time. And then on Thursday we'll come back. We'll take this to the next step. Look at another way of writing tests, which we call test-driven development, which is a lot of fun. So if we know what our class is supposed to do, we can essentially write the tests first, which is a good way. And we'll talk all about that on Thursday. Some people are hardcore. Test-driven development is the only way to do things in the industry. And other people are like, it's fun, but sometimes we do it, sometimes we don't. So not everyone is in love with it. But I think it's a great approach. And it really helps make sure that you know what you're supposed to be doing before you write any code, which is a good thing, right? The more time we spend in front designing and planning and understanding how we're about to solve the problem with our code, the more likely we are to be successful, because we're not just writing code and hoping for a good result, right? We've spent some time designing, spent some time planning, and we know what we're supposed to be doing. Does that make sense? Yeah, definitely, Blanche. Glad to have you along. All right, so let's talk about our lab assignment here. Let me go make a new link here for you for a new repository. And then we'll do, this will be lab 6 for unit tests. Lab 6, this is unit tests. So this will be due next week then. That puts us out to the 15th before class starts at 10 a.m. All right, so 10 points for this one. Like all the labs should all be 10 points. In the labs category, submit that one. Add a new labs category. Here we go. Okay, so 2151. Let's find this one. Winter. This is lab 6, right? 2151, winter 2022, lab 6. We'll do this, grab our Java template. Template. I can spell that right. There we go. And feedback pull requests. All right, so here's our link for it. We submit the feedback pull request URL. Oops, I hope if I can spell request right. I'm so glad everything gets spell checked nowadays. English is, spelling's hard. The spelling is hard. All right, so we're gonna write a class and then we're gonna write unit tests to get 100% code coverage. That's the idea here. So we're gonna write a class for, and let's see, what do we want to do for our class? So we want to, how do we write a class for item here? We'll have properties for quantity and price. So name, quantity, and price. Quantity and price. Include get methods for everything. And a toString override that returns the name and price here. Add a method purchase given a quantity. Right, so purchase like for quantity, that's probably better, right? That returns a Boolean value if there are enough to purchase. Update the quantity of the item, remove, I don't know, yeah, subtract, update the quantity of the item, subtract the number purchased. So if I have like a dozen of bags of coffee and you want to buy 4 of them, right? After that works, I have enough to sell, right? 12 is more, my quantity is more than what you want to purchase. So I can, yes, you'll get a true result back, and then my new quantity when you're done then should be the value 8, right? Our Boolean value, true, false, for method purchase here, and we should be good. So that's, yep. And it just updates the quantity here. So nothing too crazy here, and then we're going to add unit tests, ensure 100% code coverage. So both cases for purchase. So nothing too crazy for practice, right? So we had drive, we had add gas. You're just going to have purchase, right? One where you purchase a quantity that works, you get a true result, and one that you try and purchase a quantity that's too many, and you just get back a false result. Don't change the quantity at all in that case, right? If you try and buy too many, don't change the quantity at all. So if I try and buy 100 and I only have a dozen, just return a false. Don't even bother changing quantity. Right? We'll just leave it as is and tell them, nope, you couldn't do that. Because if you want to buy a certain amount, you might not be happy only getting a partial. And that, we'll just call that good. That makes sense what we're looking for item for this lab? So the unit tests both cases for purchase and the constructor. Constructor gets, right? Constructor and gets and toString. Kind of all in one test here for that. So you should have 3 test methods when you're done. Okay, so we save that one. So that's what we got the rest of today. We'll spend the rest of the time working on that one. I'm happy to bounce around, jump on screen sharing sessions with you folks, and then I'm working on getting the next Lab 4 and Project 0 graded before Thursday for you folks. So everything else has been going well with the labs. I'll take a look at this project, see how well that went for you, and we can go from there, okay? So any other thoughts, questions, or concerns? Are you folks ready to jump in? We'll spend more time on Thursday looking at unit tests. Again, we're not going to do another lab on it because we got the project coming up due. But that's what we'll work on for next week. All right, awesome. So shoot me messages, email, text, call, find me on Discord. Happy to hop around and help you out and get this lab moving, and we can go from there. So I'm not planning on putting a quiz out there for this because there's no material in the textbook for it. So we'll skip a quiz on unit tests, but we should have the last quizzes here for our object-oriented chapters. I didn't post it. Shoot. Okay, I'll post. Let me leave myself a note. Let me post the quiz for the chapters. I'll post that. I'm sorry, I forgot. So I'll post that one for the object-oriented chapters. I'll post it this week, so I can give you a week on that one, and we can go from there, okay? All right, thanks, Crow. You folks take care. Let me know what I can do to help, and I'll talk to you later. Bye, everybody.